Okay, my friends, before we get started, I want you to know I just finished writing my book about all the different areas in science and history and all of that that's just wrong, which is virtually everywhere. I keep getting these things about dark energy mystery, mounting evidence points to black holes. I show all of this stuff, as you will see, and these are the areas that are wrong, and these are basically chapters in the book, and then I am going to support them with video, or probably one video covering each topic in pretty good detail. And then we're going to have discussion about it, some kind of a forum. I'm not good at that, so somebody's going to have to do that. But we're going to go through all of the geology, chemistry, biology, history, mythology, religion, anthropology, archaeology, human development, evolution, giants, dragons, myths, dark energy, physics, light, what particles are made out of, the protons and neutrons, polar particles, the periodic table's got to change, enzymes in the bacteria in the body, in the interstitium layers, and the body is not completely understood now at all. And basically everything happens from enzymes, which are products of bacteria. Bacteria are the chemists of life. And they produce, there's thousands of different species, and we're working on right now trying to get a database of what is a healthy human body, what species live in a healthy human body versus unhealthy. So we're working on that right now. We need help on all this stuff, and it does not come. It just doesn't come. So anyway, see what I have to say today, and we need to get this as a regular, fully fledged school. And when they know that you went to Mudfossil University, they'll know that you understand reality. You haven't just been spoon-fed something that just isn't right. It's not right anymore. None of that stuff is right. I've shown it, and I will stand before any professor in any university right now, and I will discuss my evidence compared to their theories. Or my theories, but my theories are rooted in material evidence. That's what I do. All right, I asked ChatGPT if light can be accelerated, what does that do to physics? And it gives me a whole bunch of stuff about what they say has to happen. Then down here it says, if new physics, brand new physics, if light can be accelerated, it could point to new physical laws beyond our current understanding, potentially involving new dimensions, particles, or forces. Dipole electron flood theory, dipole particles are electrons. 1840 or so make up one proton. That's the new laws. That's the new particles. Okay, ChatGPT, I said, if light has mass, what does that do to physics? I believe I can show you light does have mass. Now let's see what it says. If light were to have mass, it would fundamentally alter many aspects of physics as we understand it. Everything would change. The speed of light, energy, momentum, gravity and light, quantum electromechanics, cosmology. Literally everything changes when you go to dipole electron flood theory. It says down the bottom here, in summary, assigning mass to photons, which they definitely, well, I'll show you they have mass, would require a complete overhaul of modern physics, from fundamental laws to applied technologies, profoundly changing our understanding of the universe. Okay, my friends, they just don't understand what they have already done 10 years ago. The black particle is the mass, and it's attached to the white particle as what they call a gluon. I call it a dipole electron. And there's two of them back to back, like two-bar magnets make a photon. One of them only is heat. All right, that's what heat is. It's the black and the white. Heat. White only is electricity. It's lightning. It's static. It will burn right through you to get to the black. That's how strong the white wants to get to the black. This is the strongest force that is known to mankind. If you get this separated from the black, it will want to get back to that black so bad that it will go through anything. We separated right here. You see them? This is light. So these are photons. They will have a mass, no question, and I'll show you that. Well, as a matter of fact, Fermilab says they have a mass. You see that black one? That has the mass. This came from Fermilab. And I contacted them. I said, we found your particles. They are part of light. They smash these big things together, and they see them. They see the same particles. They just don't know what they are. They have no clue. And here's what they do. They smash these huge things together like this. Boom! And they get all this debris, like protons and a neutron. Bam! And it's just nothing but a zoo of particles. We started with the tiniest particles that exist. They find the same particles we found. The black, the green, and the red. And this is right from Fermilab. This is not from me. And they also found the photons. And they found them with high energy. And they found them with low energy. And they found them with extremely low energy. And they found little bits and pieces. And then they found a lot of X particles, which are chunks. This big, that big, this big. And these are the ones that kill you, and they destroy the CMOS. We started with the littlest particles, which is what CMOS is made to see. That's why we had such magnificent results with that's just unbelievable. Now that is accelerating light. I could show you light not accelerated, and this is accelerating. And at the Venturi, it literally exploded, and it separated the white from the black. That's what generation of electricity is. That's what generation of electricity is, to get the white away from the black. And then it wants to get back so bad to the black that it runs motors and does all kinds of things, because it wants to be back on that black instantaneously. And it does. It was split apart right here just as it approached the Venturi. And right here, that's like an attosecond later. That's light going like a bazillionth of an inch and reattaching instantly back to the black. Right here is the line of reattachment, which is actually where bosons are formed. All right, this is not nothing. This is for real. And like I say, Don Lincoln at Fermilab said exactly, I agree with him, right? He says that you have the black one, which is the fixed one. I just showed you. These are his. I actually took this picture from his picture. He said this one never changes size. It's fixed. This one has no weight whatsoever. It can get big. It can get small. I agree with that 100%. And at the very bottom, he comes down and he says, in summary, the extended fixed particle has a fixed size, just the same size, and it has all the weight. And I can prove this, and I will show you this. They may have a fuzzy edge around them, which they do. The point-like particles are abstractions, zero size. There's just nothing there. And there's no weight to them, and they're all the energy. Is that white fuzzy one, is the white one, whoops, the white one right here, he's showing it red, which is, it's red when you use a red laser. It's green when you use a green. It's blue when you use a blue. And when you use just pure white light, all you see is the white, because it's all combined together. So he's saying these zero-sized particles, there's just nothing there. And I agree with that. I can't explain it, but there is nothing there, and has all the energy. It says they have an effect of the field surrounding them. Yes, it's like a balloon, like a vapor balloon. There's nothing there, basically. But when it hits another balloon of this energy, they start to glow. And that's what the impact is, the glow. You see this? When it's coming here, it's just barely glowing. Now it's starting to accelerate because of the Venturi. Venturi forces things to accelerate. And now it's starting to glow pretty good. And here it just exploded. And that's because the field is getting bigger and bigger and bigger and bigger and bigger and bigger as it's pushing against all these particles in front of it. And I'll show you how this manifests itself and how it ends up coming out the other side as Higgs fields. All right, this shows you the whole shooting match. This is light prior to acceleration. It's just beginning to accelerate. It's about right in this phase right here. You see the wave coming forward? That's a pulsed red laser. Now, why is there a wave? Because there's a particle back in this wave, but it has a big field surrounding it. All right, there's actually two gluons back here, and they have a big field surrounding it. So its field has to push through all these other particles, which have a field of their own. So they glow a little bit, and this glows a lot. It says, get out of the way, I'm coming through. And it's pulsed, it's strong compared to these. They're just laying around, sitting around doing nothing. Now this is right in a dark, dark room, just a normal room. And the light coming through has to push these out of the way. That's why we see these little glowing parts. Now, what happens as it starts to accelerate, which it is just beginning to do right now. Otherwise, you wouldn't even see this. You see that? They're all over here. And they show up here. Again, I'll tell you why they show up here. But they are here, just like this one's here. They're over here, there's over here, there's one over here, there's one over here, there's one over here, there's one over here. They're all over the place coming down because they're light particles. You never see them until they interact. This one is interacting because it's accelerating. And why it's starting to glow is because this is bouncing back at it. And about here, they just smack back together and the whole thing explodes. And here, the white particle disassociates from the black. We saw they were attached together. And right there, they disassociate and they come right back together there. Looking into this, we see the white. And then about this far out, whatever, just an inch or so out, we see these fields show up. Those are Higgs fields. And that's when the white comes back to the black and they form these little swirly disks. Now, the particles, as it accelerates, I'm going to show you what it looks like. This is the red as it accelerates. All right, we're coming in here in a neutrino phase. And this is one flavor, which is sideways neutrino, and then it flips up this way to be that type of neutrino. And then just before it hits the Venturi, it turns into a photon. And the reason is, it thinks it hit a wall. You don't get this until you don't see photons. You don't see them. You can't see them. The only reason you see it is when it bounces back from something. Then it's a photon. Well, it's bouncing back because this is pushing at it, this is pushing it. It thinks it just hit a wall. That's why it's now a photon. So we can see it in midair. That's exceptional, unusual, and CERN sees them and Fermilab see them, but they're just in a bunch of debris. So they don't have any idea what it really means. We know it started with light, and not only that, I can prove this without a shadow of doubt, because here is green. Same particle, but it's just from a different, more high-powered laser. And it is more high-powered because I could show them going through the same Venturi at the same time, and the green concusses way out here after the red. It pushes the red right out of the way and concusses way out there. Now, so we saw the red, we saw the green, we saw the acceleration. The blue accelerates even faster. Or it's actually, this is slowing down. It's coming in real fast here and slowing down. That's why you see the little wide bands there. It's so tight here. And light slows down very easily and it speeds up very easily. And this was done without a whole lot of money, and I think that's the real problem, is that it sort of takes away from what they've been doing, the funding. Because you don't really need a lot of money to do this, but we could get something out of this. Let them turn their research on something that has a possibility of doing something. What they're doing now is they're just taking energy, putting it into something so they can get that energy back. They're never even going to break even. Fusion and all that stuff doesn't work. This does. But when you have to put energy into something to get energy back out, you're just, at best, breaking even. This is for free. We pulled away the white. All right, when you pull the white away from the black, that's charging a battery. That goes down into a battery and would charge that battery, and it has no weight whatsoever, the white. All right, and I'm going to show you this factually, because I can prove everything I'm saying. Here's what happened through the Venturi. In this case, we let some black through. All right, you see the black? and the black is pushing the white. This, my friends, is a subatomic nuclear explosion. That's what it is. Which means the black and the white separated. When they're together, that's together. When they break, that's fission. When they come back together, that's fusion. And they come back together when they, like right out here, they're going to be forming back together. They'll start to reform with the Higgs fields. And I know I showed you the Higgs fields, but I've got shots, I got so many shots of this. Now, they say that these are matter and antimatter, totally the opposite. This is the matter. The dark is the dark matter. That's what you're standing on right now, is dark matter. Matter that they're showing is no. That's the glowy part. It has no weight, no anything except energy. Now, I said I can prove this, and I can. What I'm going to show you is a nuclear bomb going off, and it's going to hit a test house. And a test house is, say, like right here. When the white particles hit it, the house will just smoke up. It doesn't move. There's no weight to these particles whatsoever. They just invade other fields. All the weight and all this pushing of matter is done by the black. The white will not push matter. It will not push matter. It will invade matter. It will not push matter. You understand what I'm saying? Think about this carefully. It will invade the matter that's there. Its electron will be excessive to the number of electrons that should be in that material, but it won't push it. It'll just exceed the number, and it'll vaporize inside. Anything that's combustible will vaporize. Then the cold particle, the black one is absolutely dead cold. There's no heat whatsoever in the black one, but it's all the matter. So here's the house. Smoke, 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 bam, and the house goes. If I can show you that, I say that proves my electron flood theory. Because we're starting with a mass, which is like that, which is loaded with dark matter in the center. The explosion goes off. All the white particles take off. Then the black follows them and knocks the house down. So here comes the house. Okay, this is atom central. Boom. They just set off the atomic bomb. All right, let me back up just a step back here. What they did was they got a truck out here. They got all kinds of test equipment set up to see what happens when the atomic bomb hits this house. Now the bomb is back here, is heading this way. This side is not going to be burning up because it's not exposed to a direct hit. This will just smoke up, and then the whole house will go when the black hits. Now have it running very slow. Watch these poles. There's wires running between the poles. They will smoke up. The poles will smoke up. The house will smoke up. Everything will smoke up and just smoke. Metal objects will not burn up, and those won't burn up, these transformers. But anything that's combustible will absorb that energy, and it'll invade it, and it will combust it. Now here goes. Again, atom central. Now I got it running real slow, and I have the sound off, otherwise it makes a hell of a crazy sound. See that? No, I'm going to stop it. It just went off. What do we see? Nothing but whiteness. Just 100% whiteness. And you can see this is in the shadow, basically, so it's going this way. Here we are looking at it in a hardened bunker, so we're not getting hit with the radiation, so we can see exactly what's going on. Now, let's continue. It just popped the house. Now, the house is sitting here. Watch the smoke. I'm going to keep stopping it as we go along. Watch the poles. Watch the wires. And see what moves. Watch. It's just drifting up. Look. I don't see anything moving, do you? It's basically just vaporizing, which is my theory, which is light is atomic vapor. This is the energetic part of light, which has been separated from the dark part, which will come up and knock the hell out of this house. Not a single thing has moved here. It's just barely vaporizing. I mean, it's vaporizing like crazy, but it's just all. Now, I'm going to stop it again. The roof is gone, basically. All the combustible stuff is gone. All the face is gone. Everything is gone. Anything that could combust. And it's just sort of vaporizing. The poles, the wires. It's not blowing back out that way. It's just coming up. Now comes the black, though. All right, so here it comes. She's smoking. She's smoking. Boom. There's the black. There's nobody in the world can tell me that those aren't two separate events. Completely separate. Totally, completely separate. This is just smoking. And the other part is just stoking. It's just. So what is hitting it? It's hitting the black particles are hitting right there. Now watch what happens. It turns around and starts to come back because they're going to see it. Watch. There's a void back here. Something's got to come back into it. All right, so that's the proof right there. Nothing but burn and nothing but smash. And nothing but a subatomic nuclear explosion. You saw a nuclear explosion just a minute ago. It was an atomic bomb. This is a subatomic bomb because we're using light. That's just nothing but light. This can't hurt you. But if you can intervene where that white is and absorb it, I think we can get free energy. Now, here's what I want you to think about. I showed you that we can accelerate the light, and this is nothing more than this. It is literally this laser shooting light down, and it accelerates going through two pins here. Well, there was three actually. It doesn't matter, 2, 3, it doesn't matter. But if you have them funneling together with a rounded circle, like they were round, and it funneled the fields into the center, and the black can't get through. So we separated the black and kept it away from getting through. Now, what you want to think about is, if we can do that, we should be able to put a harvester right behind that Venturi. So here's the laser, black and white. All of a sudden, boom, only the white can get through. The black just is filtered out. And the white has to hit like a photo receiver, almost like a solar panel. It absorbs all that white energy and puts it down into a battery. There will be no weight whatsoever added to that battery. The battery will just get more and more and more energy and have no weight added to it. That means that you could literally carry around a little lunchbox like this and increase that energy so strong that you'd have a battery in there, just a small one. You won't need much, because you should be able to just create tons and tons of extra electricity on demand. You should be able to, according to these tiny, tiny, tiny little lasers, all right, and then these little receiving parts, you should be able to have thousands of them in there, thousands. And the white is a lot of energy. There's a lot of energy in that white. I can't see it's not. I cannot imagine that there isn't any. I showed you the atomic bomb going off. I showed you the separation. I showed you the burn. That's what you want. You want the burn, and there's the burn. All right, but it comes back together so instantaneously that there's no real after effect, because it just separates and comes right back. And that's dipole electron flood theory. And if we can force those particles down into a battery, or just tap right into here and just plug right into it and let it go feed right in. You needed a little bit of circuitry in there, but nothing serious. Everything's basically off the shelf right now. There's nothing to develop. It just has to be engineered correctly. And if that worked, we'd have free energy, and portable, and not destructive whatsoever. And no grid, no harm to the environment. and dirt cheap. All right, so let's clean this thing up. What is an axion? It's a dipole. It's a hypothetical elementary particle. Elementary means the smallest things there are. If they exist, it'll clean up all kinds of problems. It cleans everything up because they're dipole electrons. They still won't understand this, to be perfectly honest with you. But there's if you divided out the weight of one electron, which is the dipole, it's the black and the white, but only the black has weight. Only the black has the weight. So if you divided the weight of one electron, which a Millikan claims that an electron weighs 0.000585485 atomic mass units. And if you multiplied or divided that into one, you would find that it's right around 1839, 1840, 1836, somewhere around there, is that number of particles that weigh what a proton weighs is one atomic mass unit. All right, so here you got one atomic mass unit as a proton. All right, they think there's a couple of quarks and there's some of this and some of that and there's a zoo in here. There isn't. There's 1,800 and something particles. Now, an exact perfect number makes a proton. But you don't have to have an exact perfect number. You could have a couple of these missing. And that's no longer a proton, it's an isotope. It's almost the same thing. It would still be considered the same atom. It just doesn't have enough particles. It's an isotope. All right? And sometimes they have too many particles, and they don't want them. And then it's an isotope above its standard stable state. You've heard of stability? An atom having stability, and then it has a half-life. A half-life means it either has too many or too few, and it wants more or wants to give some up. And it will stay in an unstable state only for a certain amount of time. That's what's called a half-life. And then when it decays, it could literally go up in decay. It can bump up. Phosphorus can go up to sulfur. Phosphorus can go down to silicon. Phosphorus, I think, can go aluminum. I think when they bump up and bump down, they can go just about anywhere because all you're doing is pulling off some of these particles or adding some more. But you're not adding enough to make them automatically be something else. So they call them an isotope. And there's a bazillion different isotopes between every one of these. There's literally thousands of isotopes that they don't take into account now. They've only seen certain numbers of them. But every time you take one of these away, you have another isotope. You take another one away, take another one away, take another one away. All different isotopes. You add an extra one, and there's thousands and thousands of particles in between every one of these. So every one missing and every one extra is an isotope. And that's how biology works, is we're using half-lives of these isotopes and enzymes. And they come up to and they smack them, and they break them all up using enzymes. It's fascinating, this stuff, and I understand it very well. If anybody wants to confront me on this, I absolutely would love to do that. Somebody that knows what they're talking about. I don't want to just be told I'm an idiot. All right, I've had that plenty of times. Now, I understand the basics of how motors work and generators work. You see this? This is a little DC motor. There's AC and DC. DC is direct current. So if I put a battery on this, so this is battery driven basically. Think of it that way. If I put a battery on here and polarized this way, it drives in this direction. If I switched it, it would drive backwards. Now watch this. This is also a generator. These can be generators. If you just hook this up to like a river paddle or something like that, it would turn this and make electricity. Watch. Now I'm going to turn it one way and it'll go minus or plus, or you won't see a plus. Either there'll be no minus there or there'll be a minus. All right, there's your minus, see it? 5 volts almost. 5 point something volts. Now if I go the other way, there'll be no minus. See? All right, that's AC, DC. An AC motor, totally different. AC motor comes in and it's going back, and you have to have what's called a starting capacitor. You know what? I'm going to show you something to prove that. Because one day I went to turn on my bandsaw, it wouldn't turn on. And I said, I knew what happened. If the starting capacitor went bad, I'll show you how to tell if you ever have a motor and a starting capacitor is bad. It'll just hum. Let me show you, why not? All right, I had to cut this out one day because I needed to use the bandsaw, and the starting capacitor went bad. And I knew because when I turned it on, you hear the hum. So all I did was, I knew I could spin it and it would take off. So I cut this hole, and I never replaced the capacitor, bro. Watch this. You see? If you spin it that way, it'll take off. Now, if I spin it the other way, it'll go the other way. That's the key with an AC motor. You have to have the starting capacitor. If you had it in backwards, it would kick it to go backwards. Watch. I went this way. This time I'm going to go this way. It can go either way with it. So, of course, you don't want to do that because you're coming up instead of going down, cutting with the bandsaw. But anyway, that just proves the point. This is what an AC motor does. The DC is strictly how you put the input. This is going boom, 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 boom. And if it doesn't give it a kick to go start this way, it just keeps going, and you hear that hum. Can't you hear that hum? The hum of a bad capacitor is around you. All right, get ready. Here it goes. I'm going to turn it on, and I'm going to move it by hand so that it starts. See, it just barely took off. Now, if I spun it the other way, okay, let's get some ground rules going now. We're talking about axions, and they're a hypothetical particle. They may even solve dark matter. Well, what is an axion? Is it a dipole? Okay, chat's trying to make up its mind about axions. I asked, is an axion polar? Is that particle polar? And it says yes. Axions are hypothesized to be a type of pseudo-scalar particle. They are polar in the sense of having a directionality, a positive and a negative side, in their interactions with other particles, which are nothing more than bar magnets or fields. They interact with fields and they interact with other particles. They glue together or push apart other particles. It's as simple as that. They're nothing more than bar magnets. They are also considered a candidate for dark matter because half of them it is. Half of it's the glowy part and half of it's the dark matter. Okay, I asked, are axions the smallest particles? Well, they're not necessarily the smallest particles, and that I agree, because they can come apart. The axion is the two of them together as a bar magnet. We can literally separate them. So they say that charge, parity, symmetry, and they go through a whole bunch of stuff. But at the very end, it says that they're elementary particles, the axions, implying they are point-like, which means almost nothing there. The size in terms of mass could be very small, but this doesn't necessarily make them the smallest. Again, they can be divided. In a general sense, as mass isn't the only measure of smallness in particle physics. They don't know what the particles are made out of, so they don't know what to measure. If discovered, axions could also have implications in dark matter research as they are considered potential candidates. Yes, half of them is dark matter, the other half is the white matter. They're polar. I just said they're polar particles. They're among the smallest particles, but they can actually be divided. And two of them back to back as bar magnets make up a photon. Look at this. Do axions have mass? Those are those two little particles, the black and the white. Yes. Those hypothetical, which I show they're not hypothetical anymore, I can show them, particles are proposed, which was developed to solve this problem in quantum chromodynamics, Axions are not yet experimentally confirmed. Yes, they are. Their properties have been theoretically studied, and they have a tiny mass. They're expected to have a very small mass. Yes, it's approximately 1/2000th of a proton. So that's pretty small. Much lighter than most known particles. Agreed. The mass of an axion is not fixed, but depends on the energy scale. I agree with that too. It has a certain weight to it, which is a non-moving, just a mass of it has a weight. And that weight is the weight of one electron. It's tiny, and like I said, it's about 1/1839th of a proton. So it's a tiny, tiny little thing. And you add them all together, and you get up to 1,839 particles, and it becomes stable. And that's its zone of stability. And for some reason, they seem to chunk up in those zones and get stable, 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 bigger and bigger and bigger particles going up the periodic chart. So don't forget, axions have a weight. It's just what it says. They have a weight. And they are hypothetical, but I show they are. They're polar, and all of that stuff changes. Everything there is in physics, 100% changes. Not a single thing is correct if what I'm saying is right, and what I'm saying is correct. All right, this is ChatGPT. Again, I asked it if my atomic theory was correct, what would change? And it says if Roger Spur's dipole electron theory was correct, it could lead to significant shifts in our understanding of atomic physics. Yes, everything. Here's some possible changes. Revised atomic structure, a new atomic model, absolutely. Traditional atom models, the Bohr model and all that stuff is wrong. Quantum mechanic models might need to be reevaluated. Spur's theory could propose new arrangements of interactions between subatomic particles, that's all dipoles, affecting our comprehension of electron behavior and orbital configurations. Yes, dipole, black goes to the center, electrons coat it, and there's just as many electrons as there is dipole particles, the black ones. Now, and the electrons are the white ones, the real glowing ones. Electromagnetic interactions, yes. Energy levels and spectra, yes. Chemical bonding, yes. Because it uses all isotopes and half-lives in biology. Quantum mechanics, yes. Fundamental shift in electron theory could necessitate a reworking of quantum mechanics, 100%, including wave-particle duality. Yes, it's the same thing. The particle has a big field around it. As the particle moves, the field pushes everything out, creating a wave, and a particle is in the center. Very simple to see these. New understanding of electron behavior revolutionized technology, especially in the field of semiconductors and energy. I'm telling you that right now. Superconductivity, quantum computing, physical constants such as Planck's constant, all that stuff got to get thrown out. Others might need reinterpretation. No, throw them out. There's no laws. There's no speed of light is consistent. There's no physical constraints here at all. They don't even know what they're starting with, and they make all these laws that you have to conform to, so it's never going to be right. You can't make a law until you know what the hell you're doing. So everything would go. Physical constants of all these fine structure constants, throw them out. Others might need reinterpretation or recalibration under the new theory. Such a theory would need extensive empirical validation and might open new research avenues or refute existing models if proven consistent and predictive. It is, and it does, and it should be looked into because it could be our salvation. Okay, my friends, I'm going to leave it at this, but why don't we see what is in front of our faces? This is over 10 years ago, and I went back and forth with Fermilab, but the only person I can talk to is Don Lincoln, and he was not nice at all to me. The same particles I have shown you and show you what they do, and they do exactly what he says. The black ones have a fixed size. They have a fuzzy edge around them. The other ones are just zero size. There's nothing to them. They're the white particles. I showed you they don't knock the house down, but the black ones do. They have a field around them, and I don't know how that field gets there, but it is there. Now, want a phrase to find? Have a question? Email today at fnal.gov. It's Don Lincoln. Ask him why he won't talk to me. Why he's spending billions of our dollars and ignoring what I showed was exactly the same particles. And we use light, so we didn't have to, we actually could see them all together. I've shown it over and over. You just saw it. I think we got to talk to Don Lincoln and say, please, Don, which I have over and over. Now I'm blocked, so I can't talk to him or anybody there anymore. Or anywhere, basically, because I go outside the realm of what they're talking about. But I show my stuff with evidence. They show their stuff with little doodles that don't really have any meaning whatsoever. Because they don't know what they're seeing. All they're seeing is a bunch of trash. When we hit our particles, they go through a venturi, and they can't get away from each other. They're forced through that venturi. With them, they hit head on and they splash. They go everywhere, all kinds of... And they look for years through that stuff. We see exactly where it goes, and we can focus it, and I think we can get some energy out of it. Anyway, I'm going to leave it at that for now, but we really got to confront this. This is crazy. It's insane. The last 15 years, I can't believe the opposition to reality, to intelligence, to truth, to facts, to evidence. The pushback is just incredible from the people we trusted and the people we put in power to do the things that we wanted them to do. And they are doing the things that ingratiate themselves. And the academics, they're just using the kids. They're just using the kids as a source of money. And they're teaching them something that they were told to say, regardless of the evidence that shows that they're wrong. And I have all the evidence. So if anybody wants to confront me and say, Roger, you're spreading lies, you're being a bad person, you're doing all these things, well, come on. Talk to me. Let's see why I'm so bad. Why I am so sequestered and put off to the side and ignored and, and worse. I've been through this 15 years and I'm just still not getting anywhere. There's some people that follow me, and there's the same ones over and over and over. It's not being spread to anybody. I don't think the people that are watching me are talking too much because they're a little afraid. Everybody gets on you. They call you crazy, nasty things for thinking about these things. That you shouldn't be doing that. Well, to me, that's not good when it gets to be that way. And peer review is the only thing that holds sway anymore. If you don't get peer reviewed, nobody will take you seriously. And the peer review will only peer review if you're saying the things that they want you to say. And if they don't want you to say it, it's not peer reviewed. It can't go to be published, and nobody will ever see it. Now, academia.edu is the best source I have found to publish where nobody else will let you publish. I have like 45 papers up there on academia.edu, all kinds of different subjects. And they're very brief papers, but at least they put my point of view out there. Otherwise, you just can't do it. But anyway, I only get, a few hundred hits over the course of years with that, of academic type people. But now I'm getting a lot more. And I get a lot of more mentions. I noticed the other day they had something that had over 6,000 mentions in other papers. Now, what they're saying about me, I don't know. It's probably not good. I have no idea. But it's time to discuss this openly. That's all I'm asking for. I'm not asking for, Roger, you're right, yeah, fabulous. No, that's not what I'm asking. I'm saying, let's discuss the evidence that I have shown to support my statements. That's all. I showed the particles. All right, I love you all. Thanks. Bye.